Okay, good day ladies and gentlemen. Today we are going to do Kirchhoff's law. So please note that this video is part 2 of part 1, and to watch part 1 you can just click the link here, or you can go and check the link in the description below. So before we start solving this circuit using Kirchhoff's law, we must first understand the two laws of Kirchhoff. Kirchhoff's first law and Kirchhoff's second law. So Kirchhoff's first law states that the current entering the loop is equal to the current that is leaving the loop. So looking at this circuit, let's say the current that is supplied by this source here, which is a generator, is going to be I1. So when I1 reaches this point, it's going to split into I2 and I3. But by analyzing this circuit, we can see that I1 is equal to I2 plus I3. So this current here is going to be this current plus this current, because this current is going to be the main current. When it reaches this point, it's going to split into I2 and I3. So now to analyze this further, if you want to make I3 the subject of the formula, I3 is going to be I1 minus I2. Therefore, we can write here as I1 minus I2. We can write this. Okay, we can write this circuit that is flowing on this loop as I1 minus I2, and then I1 and I2. So now, when we consider Kirchhoff's voltage law, because to solve Kirchhoff's circuit, we must consider these two laws, Kirchhoff's current law and Kirchhoff's voltage law. So Kirchhoff's voltage law states that the algebraic sum of the voltages in a closed loop must be equal to 0. So we must consider the voltages in this closed loop, and each voltage is going to have a positive sign or a negative sign. So from this, we are now good. This is going to be positive. This is going to be negative. This source positive, negative, and this one positive and negative here. So now we are going to look at the voltages in this closed loop. In this loop, let's say this is loop 1. So looking at this loop, we are now going to look for the voltages. So when we go from this point to this point, there is no voltage drop. But when you go from this point to this point, we have two voltage drops. This voltage drop and the voltage drop that is going to be caused by this internal resistance here. So now the voltage drop here is going to be 60 volts. So what is going to be the sign of that voltage? Since when you're going from this point to this point, the sign that we came across first was what? Was this positive sign. So that means our voltage here is going to be 60. Name? Okay, please understand that. Okay, so now when we are flowing through, we're going to come across this also voltage drop by this internal resistance. So since the current here is going to be flowing down from this point to this point, and we are also going from that point to that point, that means we're going to have a positive sign. And the voltage drop here is going to be I2 times 0.3. We know that voltage is going to be IR, and it's going to be current times resistance. So when you go from this point to this point, we don't have any voltage drop. But from this point to that point, we have two voltage drops again. The voltage drop due to this resistance and due to this voltage source. So this current is going to be the same that is flowing here, because this is one loop. That means here we are also going to have what? I1. So the voltage drop here, since the current here is going to be flowing upwards, and we are also going to be flowing from this point to this point, that means here we're going to have a positive. And the voltage drop here is going to be I1 times 0.2. And then we're going to have a voltage here. The voltage that we're going to have here is going to be 80. So what is the sign of this voltage here? It's going to be negative, because when we were going from this point to this point, the voltage sign that we made first was this negative voltage, this negative sign. So that means here we are going to have what? Negative 80, which is equal to 0. So by rearranging this, that means we have 0.2 I1 plus 0.3 I2 plus 60 minus 80 is equal to 0. And then to simplify this further, we're going to have 0.2 I1 plus 0.3 I2, then 60 minus 80. 60 minus 80 is going to give us 60 minus 80 gives us minus 20. So it's going to be minus 20 is equal to 0. Then we are going to take this 20 and it's going to cross the equal sign. Then we're going to be left with 0.2 I1 plus 0.3 I2 is equal to 20. This is going to be equation 1. So now to get equation 2, we're going to consider this loop. Which is going to be loop 2. So now loop 2, we are still applying the same principles, just that now we are going to do in a different loop. So please pay attention so that we are on the same page. Okay. So now when we are going from this point to this point, we are not going to get any voltage drop. Therefore, there's nothing. But when you go from this point to this point, we have two voltages. The voltage is due to the source and the voltage drop here. So this voltage, since when we were flowing down here, we first meant a positive sign. That means we are going to have what? Positive 50. And then the voltage drop here is going to be, the sign is going to be positive. Since the current here is going to be flowing in our direction from this point to this point, that means the sign of the voltage drop here is going to be positive. And the voltage drop is going to be 1.5 times our current. We said our current is going to be I1 minus I2. And then we go from this point to this point, there is nothing. We don't have any voltage drop. But from this point to this point, we're going to have the voltage drop here, and we're going to have the voltage source here. So the voltage drop that we are going to get here now is going to become different. So the current here is going to be flowing downwards while we are going upwards. And then the current here is flowing downwards, we are going upwards. So that means if that happens, the sign is going to be negative. The sign for this voltage drop here is going to be negative. So it's going to be negative 0.3 I2. Because the current and the direction of us, we are flowing in different direction. So because we are flowing in different direction, then the sign is going to be minus. So now when we come across this source, the voltage, the sign that we saw first for this loop, it was what? It was negative. Therefore, we are going to have minus 60. Then it's equal to 0. So now to simplify this, we are going to have these are like terms. So 50 minus 60, we're going to have minus 10. And then we're gonna say 1.5 times 1, you know how to do multiplication most. So we're gonna have plus 1.5 I1, and then 1.5 times minus I2, you're gonna have minus 1.5 I2, and of minus 0.3 I2 is equal to 0. Okay. So now to further simplify this, we're gonna have, we're gonna have minus 10, and then we're gonna have plus 1.5 I1, and these are like terms. So we're gonna add them. 1.5, okay, minus 1.5 minus 0.3 gives us minus 1.8 I2 is equal to 0. And then now to rearrange this, you're going to have 1.5 I1 minus 1.8 I2. We take the 10 to the other side, it's going to be positive 10. This is going to be equation 2. So now we're going to take equation 2 and make equation 3. So take 2 and make equation 3. So we're going to make I1 subject of the formula. So we are going to be left with 1.5 I1 is equal to, we're going to have 10. Then we take this across the equal sign. Then it becomes positive 1.8 I2. And then we divide by 1.5. We divide by 1.5. We divide by 1.5. Then we are going to have I1 is equal to 10 divided by 1.5. It gives us 6.667 plus 1.8 divided by 1.5. It gives us 1.2 I2. So this is going to be our equation 3. So now to solve the final, we're gonna substitute 3 into 1. So I1 is equal to 6.667 plus 1.2 I2. So we're gonna come to equation 1. So wherever we see I1, we're gonna put this. So now here is our equation. So we're gonna write it here. So we're gonna take the equation. I'm gonna write the equation again here. Okay, let me just put it here. So here's equation 1. Equation 1 is 0.2 I1 plus 0.3 I2 is equal to 20. So I'm going to substitute this here. Wherever I see I1, I'm going to put this. So here what we have, just put it a little bit. We have 0.2, and then I1, we're going to substitute it with that 6.667 plus 1.2 I2 plus 0.3 I2 is equal to 20. And then I'm going to remove this multiplication sign. So I'm going to do 0.2 times that and 0.2 times that. So 0.2 times 6.667 gives me 1. So 0.2 times 6.667, it gives me 1.333. And then 0.2 times 1.2 gives me 0.24 I2, and then plus 0.3 I2 is equal to 20. So now I have these two, and this one is going to cross. So this plus this is going to give me 0.54 I2 is equal to 20. So I take this across the equal sign, is going to be minus 1.33. So I'm going to be left with 0.54 I2 is equal to 20 minus 1.33 is 18.67. Okay. So now I'm going to divide by 0.54, divide by 0.54, then I'm gonna get my I2, this one, and then 18.67 divided by 0.54 gives me 34.574 amps. Okay, this is I2. Now to get I1 is simple. We're just going to substitute I2 in equation 3. So equation 3 already said I1 is equal to 6.667 plus 1.2 I2. So that one is simple. So I'm just going to substitute this one here. So how do I do that? Let me just substitute. So it says I1 is equal to 6.667 plus 1.2 I2. So I2 is equal to 34.574. So I'm just gonna punch this on my calculator. Give me 48.156 amps. So this one is going to be my I1. So remember, when we go back to our first and in our circuit, we said to get I3 is equal to I1 minus I2, the current that is flowing here. Now we have this current and that current. So we eliminated I3 so that it will make our calculations easy. So now to calculate our I3 here, so we said I3 is equal to I1 minus I2. So it's going to be I1 is 48.156 minus 34.574. 48.156 minus 34.574. That one is 13.582 amps. Okay. So now I hope this helped you. But if you have any questions, please feel free to leave a comment below. I will reply taking any questions or any examples or any problems that you are facing. You can just send them directly to me or in the comment below and refer to me to the link where I can get them. Then I will try to answer them as soon as possible. So please, while we are on it, don't forget to subscribe and click the bell icon so that every time we post something, you get an alert. Thank you and enjoy your day.